Alright, this is 4.4, Fundamental Counting Rule. Now, what the book uses for the Fundamental Counting Rule is, you take the different events, 1 through n, and you multiply all the possibilities. How I like to describe it, though, is by using boxes. Right? Each of these boxes is a k. Each of these boxes is a different event. Now, inside of each of these boxes, I'm going to stick in the number of possibilities for that one event. Let's do this with an example. So if I ask the question, how many outcomes are possible when you flip a coin, then you roll a dice? All right? So what are the two events? The first event is flipping a coin, and the second event is rolling a dice. Well, when you flip a coin, how many different outcomes do you have? It's either a heads or a tails. So there's two possibilities. Now, with the dice, how many different outcomes are there? There are 6 of them. You either get a 1, a 2, a 3, a 4, a 5, or a 6. So there's 6 of them. So if I want to get the total count, I'm going to multiply the number of ways, or number of outcomes I have from flipping a coin, and the number of faces I have, or number of possibilities I have from rolling a dice. So 2 times 6 is 12. Now, what we will discover on the next video when I talk about permutations is that using these boxes and doing permutations is very, very similar, and you can actually do all of the permutations using the fundamental counting rule. It's easier, though, with bigger numbers to use the permutations, but the counting rule is a good fallback for most things that we do. Take all of the events. In this case, there was 2 events. Flip a coin, roll a dice. So there's 2 events, 2 boxes. And then how many outcomes for flipping a coin, how many outcomes for rolling a dice, multiply it together. And here, 12 was our